Hello everyone, my name is Rajat and I am part of data platform team at Zomato. So, and here I'm having Ayush with me. Today we are going to take you on a journey. So basically how we built a insights platform on top of Pinot at Zomato. Basically, I'll start with a brief about Zomato's online ordering business. So, and to give you idea of the scale at which we work. Then basically I'll point out some of the pain points earlier we were facing before introducing this platform. And then I usually cover our basically current architecture of the platform we have now. So basically, we are a tech platform which enables interactions between customers, merchants and riders. And you can see the numbers basically on a monthly level, we have approximately 200K restaurant partners and approximately 350K rider partners that are basically doing business and transactions on the app. And you can imagine like providing analytics at such large scale can be a complex process. So basically, we enable our merchant partners using our engineering capabilities. We enable our merchant partners with insights into their business. So basically, then they can track their health of their business and make it better day on day. So these are some of the metrics that we show on our basically merchant app. You can see that they can track their total sales. They can basically compare their total sales with the last month and or basically monthly on weekly levels. And to focus on basically we have a customer funnel also. So basically they can track all the impressions they are getting on the app and how their funnel is moving, how many people are viewing their basically menus on the app, and how many users are doing the transactions. So what goes behind this like page is like the part I will focus on. So basically, before creating our current platform, what we teams were doing is, so suppose I will take example of the basically order funnel. So in order funnel, we are getting events from multiple places. So a person is coming on the app, that is tracked by some other service, and order management is done by some other service. So basically, there is a no common place where someone can go and basically fetch all these metrics. So the individual teams were owning different metric, and they were building kind of a similar framework to handle the scale at which we work. So suppose we want to show a metric on our app, then what goes behind that is like someone team is owning that metric, then they will choose like which database to pick from. So generally teams, the service teams who are familiar with the online transaction type of databases, like which doesn't support analytics at a scale. So what they used to do is like they will pick a DynamoDB, or they will pick basically Elasticsearch for a use case, and that doesn't scale well with the analytics use cases as they go on. So why it will not scale? So as I already told you, that there are different services that are tracking different order life cycle, and they need to basically get events from different places and manage the life cycle of an event themselves. So that is a complex process. So basically they have to maintain the latest state. So this is a problem, like how will they handle the updates from multiple services? And even if they get the data into their database, and then they have to ensure the sanity. So like how are they going to reconcile? So suppose they have got this many orders from some other service, how are they show like these are the actual numbers that we can show. And the most complex process is, suppose even if you crack all those things, now suppose we are showing a metric on a basically daily level, and you have to break down at a basically hour level or a minute level. Then you have to re-arc your whole computation and show all these, compute all those matrices again, and then store onto your service. So basically, this whole life cycle takes around, like you can imagine, like how much time it's going to take. So considering all these issues in our current system, so basically we were looking for a solution that can basically solve all these problems in a one go. So basically, we were already running Druid for our in-house analytics, basically that we were powering. And we are aware of Pinot also, so like the data is similar. But as I mentioned, like there are use cases where we want to track the latest state of anything, so that we are getting updates via events. So that absurd kind of process, as Kartik already mentioned, is not supported in Druid. So basically, that even if you are getting multiple updates on the same order set, we are keeping multiple rows in Druid, and at the runtime, we are basically picking up the latest row in that case. So basically, that is a complex process. So we have benchmarked both Druid and Pinot for our multiple use cases and found out like on a similar infrastructure and doing the same things on Druid and Pinot. So basically, we were getting kind of 2 times the query performance on the same infrastructure. And I already mentioned like the upserts are not supported in Druid and those are supported in Pinot. High cardinality thing is like suppose you want as there are 200K merchants are live in a month. So basically, suppose we want to show on a minute level granularity how many orders they are getting in per minute. So you can imagine like 200K multiplied by the basically we want to track the data of like 6 months. It will go the dimensions will go in basically billions. So that is handled by both the cases. But where Pinot basically kind of does the thing is basically it has indexes, different kind of indexes as Karthik mentioned. So we leverage that to provide basically a millisecond latency on our system. Now Ayush will basically give the brief of the current architecture we have on our system.
Now at this point, we know that Pinot was our solution for the use case we wanted to solve. Let's deep dive to see how Pinot got integrated into our architecture. Here you can see that we have divided our architecture into 2 layers. First is the data layer, second one is the service layer. In the data layer, we mainly focus on how the data get ingested in Pinot. Pinot support both real-time and offline ingestion as informed by Sangha and Karthik as well. So for real-time ingestion, we basically leverage our events platform where we get event from our apps, our partner app, rider apps, and from backend services. So on the basis of that, we make a call whether we want to directly ingest those events into our Pinot setup, or we want to enrich them or de-aggregate them and then ingest it on our Pinot setup. So you might be thinking like what kind of aggregation we are doing that Pinot will not be able to perfectly handle or efficiently handle. These can be like the use case my friend Rajat found that we want to show the customer funnel on the partner app. For those kind of use cases, we pre-aggregated at the REST level and the time chunk level how the funnel look like, and then ingest on Pinot instead of doing the complete aggregation on Pinot itself. With this, we were able to ensure the SLA of milliseconds for those use cases. Now, since we already have an events pipeline in place, we also have added the support for users to add offline segments. So there were 2 reasons behind adding this. First, to support better evolution of business metrics and KPIs. Like when we start a project, we decide that this is how the metrics would look like. But after a while, there are certain iteration goes over it, and we want to quickly evolve to the needs. So we can basically update our real-time pipeline in a single go, just a code change or aggregation change we want to do. But for the historical data, like want to show 2 years of whole data change into the new aggregation, that we want to quickly evolve. For those, we leverage the offline segment support given by Pinot. So basically, in this case, we will have a hybrid table. One that is listening to the real-time event as well, and the other where we basically backfill the new state of the whole table. And the second use case is like there can be a certain use case that we don't want at real time. By real time, I mean 1 minute freshness, 5 minute freshness, or 10-minute freshness. And it requires whole TVs of data processing. It can be like the top selling list at a daily, weekly, or monthly level for each partner. For those use cases, we have an hourly or daily jobs on Apache Spark that pushes data into our Pinot. Now that we have the data is available on Pinot, we are basically wrapping it through our service and making it available to the services and services. Here you can see that we have made the caching available on the service itself. Since most of the use cases were on the time series basis, like daily, weekly, or monthly. So on use cases, we leverage like how the latest, what kind of caching interval you want. Like some cases we don't want caching at all, but for some cases we want at a 5-minute caching. So for those use cases, we'll basically cache the data on for those 5 minutes chunks and leverage caching here. Average our cache rate is around 40 to 50% on the whole service architecture. Now that our platform is ready, but if we not solve the certain basic use cases like make it easy to onboard, easy to ingest data, easy to serve the metric, it will end up something like this, that people will know that it can rock their world, but they don't know how to use it or how to basically leverage the platform. So for that, we have basically divided the whole journey into 3 parts. First, we have a use case identification. I think the previous slide said someone was asking what kind of fields we should send, like do we need to send the whole order data or only the order ID itself. So in this phase, we basically identify the fields we want in these use case and whether we need it a real time or an offline table. And the second part, we basically create the schema on Pinot, and on the basis of the query we want to fire, like we want to aggregate on certain field, we leverage Pinot indexes, whether we want to use the inverted index, StarTree index, or Bloom filters to ensure that the query performance always stay in milliseconds, never go above. And then we serve the metric. To make it easy to access and register any metric, we have exposure templated format where any service can come and see how all metrics are currently live if they want to edit a current live metric or want to create a new metric itself. So in this, they provide us the filters they want to apply on the table, what kind of aggregation they want to do on the table, like they want to have a simple sum, average, or max function, or they want to have a custom SQL to like using the JSON index or some other indexes in place, and then provide the reason behind, and also providing us the caching and rate limiting configuration. For some use case, we might have a very lenient rate limiting in place, but for certain use case, we want that so that a single use case don't take the whole system down. So with this, the service exposes common RPC through which service only need to provide the value of the filters they want to query. They don't have to provide the whole SQL. They only need to have a knowledge of those filters they want to leverage. So these are the sums benchmarking we did it. So we were able to, we benchmark at a 35K RPM and with a P95 of less than 100 ms for 30 minutes. So while taking it live, we wanted to test the limit of our platform, like how far we can take it without breaking anything. So here you can see that Redis is also in the picture. So for stress testing it, we removed the Redis and only power to the Pinot. So we were able to power around 90K RPM with a P99.9 at around 600 ms. So the impact of this platform, like I said, quicker evolution of business metrics and KPI, new use case go live in a flash. So this free up the team bandwidth, which earlier was in months, like they have to identify a use case, whether they want DynamoDB table or Elasticsearch, then have to ingest the data on them, create a whole new set of things, which every team was working in silos. They don't have a common framework for them. With this, the new use cases go live in days only. For another benchmarking metric, like we were ingesting a certain use case which had around 10 billion records. So we were able to backfill around 2 billion records per hour. And the app screenshot that we showed for the partner app, it was powered by initially by the service, DynamoDB itself. When we move it to our service, we saw a 90% reduction in homepage load time from to around 30 ms.
When you were powering it from application, the use cases you could have served would have been much lesser. Now, since you are not hitting your primary application database, you can show much more richly.
Yeah, you can basically show much more analytical use cases.
Earlier, basically, the customer, we are not able to show the customer funnel itself. So now we are able to show that, and we are able to show the ad metrics.
Like we can show the complete funnel, how the metric, what kind of, any kind of analytical use case we want. Question, we are open for question.
There is one on the chat.
Let's see.
Latest.
So this benchmark, you can take the question.
Okay. So Manish is asking to explain how we handle backfilling records again. So in Pinot, we basically can directly ingest offline segment through Apache Spark jobs. So we leverage Spark to backfill the record in Pinot tables. Yes, Pankaj is asking, does Pinot support hybrid table? Yes, Pinot basically support hybrid table as mentioned by Karthik.
So the benchmarking that you were explaining, since this Pinot is a processing engine, so how the whole benchmarking you did it? So you started maybe a transactional databases and maybe increased the rights to it and started a lot more partitions on the Kafka and started consuming more.
No, this benchmarking is all about how we basically serve those metrics to the end user. This benchmarking is not about how Pinot ingested the data.
So the stress testing or Pinot that will only come in ideally I feel when the segments are getting updated and that real time it is updating those metrics and then serving it.
Yes.
And this time I think the segments are not getting updated.
Yeah, they were getting updated. We have the ingestion on of the whole time.
Business was 24/7, right? So there was
Nearly some confusion about the hybrid. These are mostly like how many queries that can be served in parallel through Pinot from different use cases. The benchmarking that.
Can you repeat the question?
Okay, sorry. What I was saying, the benchmarking that you have done. So this is like web transaction types. So basically, distinct number of queries that can be fired in parallel to the Pinot, and that how many it can serve in parallel. That is the benchmarking.
Yes, essentially.
when you ingest those data from S3 buckets, like do you see any latency increase during that time? Let's say if you are inserting TVs or TVs of data from the bucket using Spark block, does that add any additional latency? No. So is the cluster provision to be that big, or do you think read cluster?
Yeah,
So I can.
It was done by the Spark itself. It is creating the segment. We are just loading the metadata into Pinot.
Yeah,
So
exactly.
basically, servers are not doing any heavy lifting.
Okay, segments are created by the medians.
Yeah, we can use media also, and we can basically just integrate a connector, and we can create segments through Spark itself.
So you have a Spark connector for creating.
Yeah, so that only just creates the segments, copies it to S3, and then updates the metadata like in Zookeeper. That's it.
Also, like, do you support joins?
Joins in the earlier version.
And the join would essentially be done at the broker level.
No, so basically both broker and servers are involved in that because you have to shuffle the data.
The most of the work would be at the broker level. But you need to fetch some data from different servers and then do the application level join or like whatever join you are doing.
Yeah, so basically it's not even at the broker level. That responsibility is again in the new engine is distributed at the servers only because we want to keep brokers at lightweight as possible. Their job should only be to compile the query and forward it to servers and just compile the results. They should not do a lot of basically merging of the keys and everything.
So if most of my queries are like join heavy, then essentially I need to scale my
Servers only. Servers are the main thing you need to scale horizontally and vertically.
Yes.
Can it process by more than one?
Yes, because since each table had multiple segments and segment will be equally divided among the servers, so the query will be basically processed by
It
distributor.
depends upon your basically query time range that you are querying. So
the service that you have created on top of the we also have some kind of service which basically checks like this filter would not be efficient or do we have or that is still manually done?
So for now, we leverage the API exposed by Pinot itself. So while creating any new use case, there is an API to check the configuration you might have to update for the table, which basically give you an example like for you, how does this work is like, you know your use case, you know the table you are going to create. So it also asks the parameter, the type of query you are going to run on it, and the factor. Factor can be the ratio on which these queries will run. On the basis of that query and the table configuration, Pinot will advise to basically tune your indexes and all.
Something like analyze kind of API.
Yeah, Pinot provides the API itself.
You have both. You have now both terms in place, Druid and like. So when will you use this one, and when you are going to use Druid?
basically currently earlier we were using Druid for our in-house analytics, so we haven't touched that as of now. But we will be planning to move basically to a single system in the
From what it looks like now, for you, there's no reason that anything new you are building for real time. No advantage as such which it has over people.
Yeah, there is one basically the ease of handling the basically suppose if there is a new you want to add a new table. So basically the UI of Druid is quite user friendly. Basically you can go through the UI and basically submit all the tasks you want to do. So and you can see the real time logs on the UI itself. Basically that part is great about Druid. But I think that is will be there in Pinot in next few releases, I guess.
That is actually
Perspective, are they comparable?
Yeah, they are kind of similar. So basically, we are running as we have built expertise on running Druid. So they have kind of similar components in them. So basically, we already knew like what kind of configuration and what kind of instances we want to run our basically Pinot cluster. So basically, we just ramped up and set up these clusters.
I think Druid because पुराना भी है तो उसका connector ecosystem भी काफी
Yes.
How do you monitor things if you are showing your real-time metrics of budget? And let's say, for some reason your metrics are wrong or the strings not adjusted, how do you monitor?
Ideally, we should have an anomaly detection or certain system in place which checks through this. For now, we have the
Basically, there are
validation.
two parts to it. So basically, one is the real-time data we are coming, which is coming into the system, and some of the matrices we are basically using Spark to dump that through Pinot. So on the basically Spark kind of thing, we have a basically checks and validation queries before pushing data to Pinot. We check like if these matrices make sense or not. For the real-time system, basically we are exploring basically a kind of third eye. So basically, we can just do a anomaly detection on the real time itself, so that we are not showing any wrong metric on this here.
Because certain things like if you're showing today's sales, right? If you go wrong, then there can be an operational challenge for the folks on ground. But in some of those cases, it might be okay for you to have a system where you say that I have a problem in my pipeline in ingesting data. Then you can say that okay, the data is not available for
Basically on the UI itself, we show like the last updated to the basically merchant itself, so that they don't panic. Even if the data is at lag, so they will see that like this data is updated up to this second.
Or does it even feedback to transfer real time, or will do the validation after certain interval?
On the real time, currently we are not doing, but we will run a basically kind of anomaly detection the real time itself. On the batch, we have kind of a validation checks.
In the real time, we just aggregate the data and showing up,
Yeah.
then again after a certain threshold, or like
Yeah.
point of time,
Yeah.
you will have your feedback to that.
Yes, so that will be there.
You also have the option to partners to look at the past data and analytics platform itself, or do you have any limitation?
Yeah, we have basically we stored the data in Pinot for the last 1 year, so they can have a good view of the historical data as well. So Pinot basically exposes the live stream lag and the consumption rate because it's managed an external checkpointing. It doesn't do checkpointing through Kafka consumer protocol. So these metrics are exposed by Pinot itself.
What are those metrics in the first place?
0.12 version, latest version, they basically started exposing in a Grafana Prometheus metrics.
So to hack that, basically earlier what we were using, so on each individual table we are firing a query and checking like what is the latest set in every 1 minute or every 5 minutes. So we use that hack into Druid when there were no matrices, so we can do the similar thing over here.
But now like that is available in the normal Prometheus metrics of them.
That's that we are.
Is there any resource manager sort of thing in, like if I want to restrict a particular user to use only X amount of resource, like while querying or writing?
Like you can do role-based access, but what do you mean by restricting the resource, like during the query side?
For example, single store provides you like user-based resource manager, wherein like you can restrict a user to use only X% of CPU or X% of memory.
I don't
for
know
their
that.
query.
So yeah, not at a user level, but it will be more of a, let's say, use case level. So you can designate certain servers to, basically the concept of multi-tenancy is inherent. You can, let's say there are 5 servers, you can constitute server A and B as tenant A, C, D, E as tenant B, and then each powering specific queries. That A does not hamper with B, so on and so forth. Not at a user level, at a use case level, at a, let's say, group
So
level.
at the controller level, we can considering that this type of query will go only to this tenant.
Yeah.
So that won't be a perfect answer to your question, but we can use a query killer also. So basically, suppose if it's running beyond that will kill the query.
Timeout is you can configure both at a query level as well as at a server level.